So there's still a minute or so, and there's a couple of people missing, so we'll wait a little bit for them to get back.
Excuse me, Alex.
Yeah.
Am I able to do the Monday class interview online, or do you want me to come in?
No, well, like I said, you probably should come in because, like
Yeah.
I said, I'm in the classroom with everyone else that's from Monday class.
Mm.
And if I give you all the details of the problem today, everyone else is going to be able to hear the same problems, and it defeats the purpose of having the interview for everyone else. You know what I mean?
I'm talking about maybe on Thursday. Is there many people in your Thursday class? Or?
Yeah, you can do it in Thursday class. I don't think there's too many from this class at 10, so we can keep it a little bit private. But obviously, it seems like you're not able to make it into physical classroom for quite a few weeks now. Is there an issue?
Yeah, I might write to you actually. So,
yeah, write to me because obviously, from what I can see, you're registered as a face-to-face class student.
Yeah.
But you're not attending face-to-face, you know what I mean?
Yeah.
It's not just one session, it's quite a few weeks now.
Yeah.
All right, so write to me, let me know. Obviously, It's not a huge problem as long as we can work around it, but if it's an ongoing thing, it might be in the future better for you to register as a virtual class student.
Okay, yeah.
You know what I mean?
Yeah. Okay, thanks.
Yeah. All right, guys. So I think we're still waiting for Lauren. She's definitely always here. And I'm just taking the role on the other screen as well. But we'll get started in a minute or so. Oh, here comes Lauren. Speaking of the devil. Come on in, Lauren. Pavel's here. Tiff is here. Tiff is not here. And Mohammed is not here. Oh, is Mohammed here, by the way? Are you online? Sorry, just double checking. Yeah, no.
I think he was here earlier.
Yeah, you were here earlier, but are you the Mohammed in my class? Because it says here Mohammed Safi.
Hi, Alex. This is me, Mohammed Safi.
Yeah, so you're not the Mohammed from my class then. You're not the Mohammed WhatsApp, right?
No, I'm not that one. Yeah.
Okay, no worries. It's just obviously online, I can't see your face, and I'm getting myself confused with a Mohammed that's normally in my class. That's fine, no problem with you attending my classes anyway, but it's just, I was just a little bit confused with the person in my class, okay?
No, you're all right, yeah.
Yeah, all good. So let's, now that I think everyone's back here now, so let's actually now talk business. All right, what I mean by talk business. The business of TAFE is assessments and passing of assessments. That's the business of TAFE. So let's have a look at where we are, because I don't want to lose track of where we are, where we're heading, and what things needs to be done when. So if I open up the study schedule, as always, and let's review where we should be, what we need to do by the time we're here. So if we look at our date today, today's the 11th, so therefore this week was the week of the 9th. If you look at this, we said that this week we're supposed to do the IPv6, which we said you'll have to look at in your own time because it's not part of the assessments, and we spent a lot more time in doing the IPv4 than it was planned, only because of the need to, not because I enjoy the IPv4 as much as that, but we needed to. I felt like we needed to go that much slower because of what I'm viewing in the classroom and how we're sort of progressing. So I made that adjustment on the fly, and hopefully you agree with me. But unfortunately, if you want to do IPv6, you have to do it in your own time. And like I said, it's not part of the assessment. So even if you totally missed it, it's not an end of the world for you from a technical point of view. As in, you probably noticed we haven't been using IPv6 in our practical work much at all in any of the other subjects. And trust me, we won't. And we obviously won't be covering it as part of our assessments. So that's why I felt like that was an easy one to skip over. The next one is the ICMP. If you look at, that's what we're going to look at next. And obviously next week we're going to finish off the OSI layers, transport application layer. That's actually the TCP/IP layers, but the application layer will be inclusive of the session, presentation, and application layers. But if you look at this thing that's in bold, I've been sort of drawing our attention to it for a couple of weeks now. We are meant to be doing the interview this week. All right, so what is the interview? You're probably saying to me, what is the interview? What are you talking about with the interview? The interview is part of assessment 1. And as you know, we've been looking at assessment 1 in this class anyway, along the way. And we've been reviewing the questions. And obviously, if you forgot what we talked about each question, you can go look at our recordings. But if you keep on going, and we covered all this in our discussions, but if you keep on going, keep on going, we have a where is it? Interview. I think we're past it. Sorry. So schedule a time to meet face-to-face in class or online with the finance manager, which is your lecturer, and to discuss the following. Okay, so what I said is that we're not going to necessarily I want us to discuss in that meeting just for our class, because the part of it is basically the communication skills, as always. Part of it is to sort of get feedback from the client about your plan, about what you decided, what you want to purchase. And I said that we're going to concentrate on our discussions on basically the internet service plan, the ISP, the NBN plan, details of that, including the cost, the download speed, the static IP address, all that kind of stuff. And also the switch. The key thing to this assignment was to select a Cisco switch that met all the requirements for the company, as well as those 3 critical requirements that you identified as part of task 1, question 3. And obviously, we can't sort of do this interview without you having at least a go at doing all those things and having something in mind. So what I said last time was, if you have those things prepared, we're going to start doing the interviews as of today. So you'll see that we'll finish up the ICMP very quickly. And then we'll have time to do the interview. If you're ready, just let me know. We can step out and do the interview. But if you're not ready, we really need to do it before we go on. We finish up next week. All right. It doesn't have to be today. I have an IT prac on Thursdays as well. So tomorrow at 11:30 to 1:30 in A105 or online through the Collaborate link. We can do the interview then as well. But just be aware that I'll be in a physical classroom as well, like I told Jaden, that if we do talk about stuff, it's not going to be in the private of just one-on-one in a different room. But if you're in person here, we can just step out, go to a different classroom, and just do it one-on-one. Okay, so if you feel more at ease because of the shyness or something, being here in person. So that's what I want to do. So you'll see that, hey, next week, that's it. The week after that is really for those term subjects where we need to finish up assessments. You see how there's no classes in week 9. Okay, there's no classes in week 9, and the term break is not 3 weeks, by the way. It's 2 weeks. Let me just double check that. Yeah, it is 2 weeks. Okay, so this is not correct. You can see that that's a week beginning 14th. So let's have a look. So this 23rd is that one. So really, if we look at the dates, it's actually 2 weeks anyway. Okay, so this diagram is not correct. In a sense, it's saying 3 weeks. It's only 2 weeks term break. Okay, and we're back on the week of the 14th. So are we all clear about that? All right, so I don't want people to miss out the first week, because if you look at the first week back, for us, that would be the 15th, 16th of October. That is when our assignment 1 is due. And as usual, if you don't submit the assignment on the due date, it will count as your second attempt. And obviously for this assignment, the assignment 1 is pretty big. You want to make sure you actually have a go at everything. And if there's something that's not good or it's not sufficient, not pass level, then I will give you feedback for you to go fix it. If you leave it blank, if you do not submit anything, the only feedback I can give you is you haven't done that question or you haven't submitted anything. You see how I'm going with this? If you actually have a good go at it, you're 85% correct or even 70% correct, I can say, hey, you need to include this bit, you need to discuss this bit more, you need to like look at that recording that we talked about, whatever, and then hopefully that will help you fix it for the resubmission. I'm not saying anyone would need a resit. Fingers crossed, everyone will be passing first go. Yeah, easy. That's what I want to do, because that's a lot less work if I can go through your questions, see all the perfect answers, and tick you off, and happy days, right? So when I have to give you feedback, that's not necessarily easy for me either, as in it's a lot of work to give you feedback and to explain why you need to improve and what you need to improve. So ideally, you'll do a perfect job, and then we all get a pass and we're all happy. But just keep that date in mind. So if you do not do the interview by that time, there's no other result besides resubmit because you haven't done the interview. Okay, so you'll get the week 9 to take and a couple of days before that assignment's due to finish it off. So that's plenty of time, and we have discussed the questions to even help you with that little bit more. Oops. I'm gonna give you a link. Okay, so bear with me. Let me just find something for you. I'm going to give you a link of a video I made, not for this group, but previous groups. Let me just get this. So I'll bring it over to the screen again. So basically, this is this is a video I've made. You know how we've been going through the questions week to week and stuff like that. So this video basically is me going through the same questions with a different group of students, but instead of actually how long is this? 29 minutes. Instead of actually being different days, different sections, I sort of chopped it up and put it all together. It was over the course of the whole term as well, like what we did. But basically, no, this is different. Wrong one. Sorry, wrong video. Wrong video altogether. Bear with me 1 second. So I thought that was a little bit short. All right, here, this is better. All right, so this one's a little bit better. So it's hour 40 instead of the 30 minutes. But basically, this is me with the questions, chopping up the explanation of the questions and stuff like that. So I'll give you this link. And obviously, if you want to pass it on to your other friends which are not here right this second, you're welcome to do so. But this is there to help you, making sure that you've understood the questions. Okay, so all those discussions we've been having, it's just basically chopped up and put into the same video instead of you going to 6 different videos, that because we've made 6 different recordings and stuff like that. All right, so that's a resource you can use to help you complete the assessments. But like I said, it's the same thing we've been doing in our class anyway, where we've actually just been talking about the questions. So does anyone want to do the interview today? No? All right, next week, 100%, we need to do it. Okay, I know it sounds like I'm putting the hard word on, but it's a fact of life. Okay, next week is our last opportunity to do it. Then we have the term break. Then we come back and we submit it. If it's not done, then when are we supposed to do it, right? So next week, make sure you are able to do the interview at the latest. All right, let's get back to learning, not the business. Business is business, but learning is supposed to be a little bit more fun. But the business part is where we pass or fail. Mohammed, you got your hand up. What's up?
Hi, Alex. Sorry to interrupt you, but my question is, first we have to do that chart and submit the assignment for the interview.
So basically, you'll have to talk to your specific lecturer who's going to do the interview with you. But what I'm saying is that my students, when we do the interview, we're going to obviously, you should have had a great look at everything up to that stage. And we're going to mainly concentrate on the MBN and the switch you've selected. But we're going to talk a lot more in depth about those things. But obviously, you should have an idea of the timetable and what things are going to be delivered, what's installed first in the order of things, and what kind of downtime we're looking at and that kind of stuff as well. Okay?
Yep.
Okay, so but if you have a specific question on the assessment, you should talk to the lecturer who's going to mark your assessment.
Yep.
If you know what I mean, okay?
Yeah.
Because I can't say how your teacher is going to do the interview with you specifically because he's a different teacher. I don't manage his class, okay?
Yep. All good. Yep.
Okay.
Thanks.
So I can only talk about my class, and I think it's generally the same across the board anyway, but I can't talk for another lecturer.
Okay.
Okay, but the key thing is the communication skills that we need to mark off, and also obviously has to be contextualized into the scenario of getting information, giving information to your client. So that's the key things.
Okay.
All right, let's get on to the topic at hand, which is the ICMP. You probably heard me say ICMP already. Okay, ICMP is a suite of protocols or suite of utilities that's for us to test or do diagnostics. So, for example, ping is part of the ICMP. Bear with me. So I'm just getting myself organized on the other screen. So the ping is something, wrong one. The ping is something you're used to. So here we go. So today we're going to look at ICMP and specifically the ping and traceroute utilities and explain what they're used for. Okay. So ICMP stands for Internet Control Message Protocol, but it's pretty much for diagnostics. Okay, so it provides feedbacks for related issues, for issues that are related to the processing of IP packets under certain conditions. Obviously, there's going to be ICMP v4 for TCP/IP version 4, but there's also going to be ICMP v6, which is for that IPv6. Okay, so basically, let's just see in action, and it's pretty obvious what kind of things we can do with it. Okay, so let me just start a command prompt as we've done so many times before in our subjects. and you'll probably need to do it in your practical test, and you probably in your everyday work life you'll be needing to do this. So from the command prompt, remember my first thing about troubleshooting is if you remember that day we had the problems, first thing is well, can I even ping Google? Yeah, remember me going, can I ping Google? If I have networking issues, can I ping Google? And the answer in this case is yes, because I'm using the ping utility, which is part of the ICMP diagnostic tools, and I'm saying go do an echo request. That's what ping is. It comes from the old naval terms, like when you have the submarines and you got warships looking for the submarines, you might go send a sonar, go ping, and obviously if that sound waves hit something, it bounces back, and then you can see what's under the water, basically. Instead of us doing this, because we can't see the other computer, the Google Arc, it's across the internet, it's all cloudy and I can't see a thing. So what I'm doing is I'm saying, hey, if you're live and you're on, reply. That's what it's saying, echo requests. And basically, if we look at the output of this, it's saying ping www.google.com, and we know that's not an IP address, that's actually a fully qualified domain name, isn't it? It's a DNS name. So knowing that's a DNS name, you notice that the next thing is the actual IP address I'm going to ping. So from that, I also know that my DNS server that I've been configured to use is also working. It's resolving this fully qualified domain name into an IP address, and then I'm pinging it, and then I've got 4 replies from the same computer. So from that result, I can see, hey, awesome, everything's working. Okay, so hopefully you can see that these are 4 replies. If I'm getting a reply, that means everything between me and the www.google.com is working and configured correctly. Through one action, one command, I've confirmed my DNS is working, my gateway is working, my my network cable is plugged in properly, my switch is working, and everything between me and my ISP as well as Google, all those millions of devices possibly, or not millions, but all those devices are perfectly working fine. But what if I don't get a reply? So if I don't get a reply, let's make up something that I can't ping, www.com. Well, first of all, in this case, it's saying, oh, we could not find this. Basically, that's telling me the DNS could not resolve that IP address. Okay, assuming this is a proper DNS name that it's well known, right? Then there's a problem with me and my DNS server. Okay, so then remember we can also ping an IP address, and I like to ping the 8.8.8.8, which is instead of ping www.google.com, I'm pinging quad 8. Quad 8 is actually Google's DNS server. And again, in this case, I've got a reply, which is good. Everything's awesome again. But if I ping an IP address, and I don't get a reply, request timed out. Okay, so this is all those positive results, meaning everything's working. But if I get a result where it's ping request timed out, or no route to host, or something like that, then that's telling me there's a problem. Okay, it's 100% loss, which is good, which is bad, sorry. And here it's 100% receive, 0% loss, then that's good. All right, but also from our results, you can see, hey, you can see that's 21 milliseconds, 20 milliseconds. That's the time, the lag, the latency. And obviously, the lower this number, the better it is. And you can see that's about the same for both these locations. But then you also see there's a time to live. I think we mentioned this before. Let me do an IP config, and I'll ping my local gateway. So if I couldn't ping the IP address, then the next step would be to ping my local gateway, because the local gateway is actually on my subnet, so I don't need to go through a router. So 10.62.3.1. 10.62.3.1 is the IP address, and you can see that's very quick, less than 1 millisecond at times, and you can see the TTL is 255. Ooh, That's different to this TTL, isn't it? 116. If you remember, we said that the TTL is basically ticking down as we're going through devices on the internet. Okay, so it's meant to so that your ping doesn't just get into some sort of loop. Just like if you think about the roads, just imagine you went on the Britannia roundabout and suddenly someone blocked off all the exits off the roundabout. You could just be going around the roundabout forever, couldn't you? With no exits. So that's what could happen in the internet when you go between different routers and because there's some problem that's actually was to stop you from being able to get to the location. So basically, once this tick down to 0, it just gets trashed. If it gets thrown away, it just disappears. Don't waste everyone else's time by going loops forever. It just disappears. That's the point of this time to live. But this time to live obviously gives us another indication as well. So it's almost like how far away the two devices are. So this on my local gateway, I can see it's 255. That's pretty much the maximum number. So there's directly on the same network. Whereas this one, it's almost like, it's more than halfway down, isn't it? So there's a lot of devices I've gone through to get here. And if I ping something else, hopefully it'll give a different number. Ping www.apple.com. Look at that. That TTL is even smaller. And look at the lag. It's even higher. So you can, so from those two results, or three results, I'll ping Google again. From those three results, you can see that this 255 being on the local subnet or local network, this Google, which is giving me a 116, which is, if it's ticking down, that's a lot bigger than the 55. But if I look at my lag, which is the milliseconds, this is actually a little bit higher than this one. Maybe it's because we're, let's see how we do. Yeah, it's about the same. Let's do Apple again. Yeah, that's about the same. So even though there's more, it's further away, it seems like the time is faster to go to Apple than to Google. Can anyone think of why? Yeah, just because I always, like me personally, and you as someone who wants to be in IT, should always be thinking why.
Maybe it's physically farther away.
Yeah, it could be physically further away, but yeah, you're right, could be. But it could also be the actual devices and the actual connections. Are they actually slower? So you know that if I go through a gigabit link, I might get a certain delay. But if I go through a 10 gigabit link, it's a different delay. So just because this is further away from a point of view of amount of devices, doesn't mean that every connection to those devices is not a lot faster than this one. Okay, so we don't know. That's the problem. We don't know the speeds. It could be any speeds, and it could be a different route we take every time. So we don't know. So which now brings us to the next one. Trace search. Trace route, if you want to think of it. www.google.com. And basically this trace route, or trace it, allows us to visualize all the devices it's going through as it makes its way to the final destination. But it's only going to give you a maximum of 30 hops. Okay, so Google, okay, that's Google's IP address that we got before. But you can see that the first stop along the way is our local gateway. So if you remember, I pinged my local gateway here. So that's my gateway. That's my router. Then I'm going through this device. Well, I don't know what that is, but I could possibly look it up later. And then it's going through this device, it's going through this device, it's going through all these devices, and eventually it's going here. And it's going, but from that's you're probably going, what? That doesn't look like www.google.com. Don't forget, www.google.com is just a name to a computer. In fact, www is alias usually to a server name. Alias meaning another name, a nickname. So reality is this server is actually called Sydney 15S15 dash in whatever, you know, it's probably got a naming convention that makes sense to whoever designed it. From what I can tell, it looks like it's in Sydney. Okay, that's as far as I can tell. But it's also the same computer that's Google. So a computer can have multiple names. It doesn't have to have one. All right, so that's 12 hops. Okay, and if we look at this, these are really fast. And this is where this is quite fast, 10 milliseconds, and then after this point, it becomes 20 odd milliseconds. Okay, so this is it does it 3 times, and basically this is the first, second, third, and you can see these are pretty consistent. This is fairly consistent as well, but you can see that this one, these two are 24, but this one's a 63. So that one was a bit of lag for some reason there. We don't know why. It could be just that it was really busy at that time. It's just think of your, Anzac Highway at 5 p.m. It could be that it was congestion. Okay, so let's try Apple. Trace. All right, so that's the IP address. This is the path it's taking. Ooh, there's one. Okay, so if we look at this, this has gone 15 hops. This is 12, so this is further away, like we said before. Remember? We said Apple was further away. It's by a couple of hops away in this case. Don't forget, every time your traffic goes on the internet from your computer to a destination computer, it doesn't mean it's always going to go the same direction or the same way. Depends on the situation, depends on congestion, depends on what links are down, what links are up, what links are being used, and so forth. But if we look at this and compare the two, you can see the first stop is always our local gateway, right? Of course, you expect it. You can't get out of this network without going for our gateway. The next one is, oh, this is different. We've gone a different path to this one. So this one is going to a different node. So it's taking a totally different direction. Well, as you expect. And you can see from there, it's different. And, oh, look at this. This is funny. Even though we've gone a different direction here to here, we've gone back to the same server on this one. Okay, that's what I'm talking about. I'm saying, even though it might take a different direction, it might, it's just like you going to the airport. I can take 20 different, routes to or 20 different driving routes. It's still called routes, isn't it? 20 different routes to get to the airport, but eventually I have to, in this case, I've got to the same point anyway. And if we look at the next one, oh, that's the same point. So this might be some consistent link, and you can see that this one's going to Melbourne instead of Sydney. It's going to Melbourne somewhere. So there might be just a consistent link that there's only one direction out of South Australia, and we have to go through them because of our ISP. Okay. So you can see that becomes consistent at this point in time. Let's see, that's New South Wales though. That's Victoria, Warrnambool, Victoria, I'm guessing. So after that, it becomes different again, okay? And then eventually we get here. But if you look at the lag, remember those times, you can see all of these links, by the looks of it, are generally faster than these links. You get what I'm saying, guys? So they're faster, as in there's less lag. All right. What if, so that's a couple of the commands. What if I want to look up what this computer is, 10.66.34.97. We can use the NS lookup. This is not part of ICMP, but just because I'm curious, remember, why always asking those questions. What is 10.66.34.97? So you know how we can do NS lookup for names, to DNS names to IP addresses? We can do the reverse. We can do the reverse and look up names to IP addresses to name. But in this case, I couldn't find it. Okay, that's fine. If it can't find it, it just means it doesn't have a reverse lookup zone for this IP address. Okay, not a big deal. But let's get back to our PowerPoint. So, someone's got their hand up. Let me just see what's going on. Sorry, did someone say something?
Yeah, it's me, Jaden.
Yeah, Jaden, what's up?
You know how Apple's less laggy?
Not laggy, Apple's faster.
Yeah, faster, so less laggy. Like, why is that though?
Yeah.
Why is it less laggy than Google?
I think we spoke about it. We said that it could be literally faster connections.
Oh yeah, the
okay,
like connections or whatever.
Yeah,
or the more,
Okay, so I think we talked. We don't know for sure because obviously we don't know every connection that's in there. But I'm just with an educated guess. It could be that even though it's going through more hops, those connections might be actually faster or higher bandwidth, and it also might be less congestion on those links.
Oh, okay.
So those are the things I'm guessing. Those are not the things I know for sure, but those are the things that I'm guessing, and they could be the reasons. Okay?
Yeah, thank you.
So, yeah, no worries. So I don't know for sure. I'm just guessing those reasons. All right, so the host reachability. So ICMP messages. So ICMP echo, remember the ping is an echo request. Echo messages can be used to test the reachability of a host. Can I get to there? Well, in order to get to there, we've got to go through this switch, this network, this router, this other router, this switch, and then to that host. If at any one of these points where the network is broken or the switch is not working or the router is not configured correctly or something's not right, then we'll never get there. So by sending a ping all the way here and getting a reply all the way back, I am basically confirming that every physical device and physical equipment as well as the configuration of it is configured correctly and working and functionally correctly. Okay. Well, there's a couple of other error messages as well. So, for example, for us, it was timed out in our example, but you can have a look at these ones: net unreachable, host unreachable, protocol unreachable, port unreachable. These are other messages, and most often you don't even see these ones. It's either timed out or host unreachable. So, if an ICMP destination unreachable message can be used to notify the source that destination or service is not reachable or unreachable. So this code, this ICMP message would include a code indicating why the message is not delivered. And if it's unreachable, if you're getting these unreachable messages, which is different to timeout, let me see. So if you remember, we had up here, we had a timeout, didn't we? All right, that's a little bit different to unreachable. I'll tell you the difference. So if I do an IP config, let's have a look. Oh, yeah. All right. So it doesn't show, but let me just ping 192.168.11.63, and I'm gonna get a unreachable. Okay, I'm gonna well, so change the timeout. Timeout is what I was expecting, to be honest, not the unreachable one. So in this case, it's timed out is the proper answer. But in here, it's timed out because what's the difference between timeout and unreachable? Unreachable means you do not have a route to that host, whereas timed out means you can get to that host if it was on, if everything else was working. Okay, so you're probably thinking, well, what? What's the difference? Difference is that if I'm getting the unreachable one, host unreachable or net unreachable, it's basically telling me my router or my computer doesn't know how to get there. Whereas timeout, basically telling me something's wrong. Okay, something's not working. I could get there if everything was working, but something's not working. So based on those two messages, sometimes it makes a difference because obviously if it's unreachable, then I have to investigate, hey, does my router have in its routing table a way to get to that network? Or does it have a default route that it can forward to, just like in our gateway, maybe to ISP. Where if it's timed out, then the problem is not my router, not necessarily my router. It could be anything in between those two locations. All right, so there's also these messages, expired in transit, so that's the time to live. So that's what I'm saying. If you're trying to ping something that you're never going to get to, and you're going to get a routing loop, and that's what's happened here. It's pinged the 8.8.8, but the person who set up this probably configured a routing loop so that the routers are just sending it back and forth between the routers and never being able to get there. And so when the time to live counter gets to 0, it just gives you this message, meaning, hey, we're not going to waste everyone else's time now because it's not getting there, it's expired. We're just going to drop the packet from the network. And from here, the time exceeded message are used by the traceroute protocol. And basically that's telling us there's a problem as well. So ping is on every device, every operating system, anything that uses TCP/IP basically. Okay, ping is ubiquitous. So what does that mean? That means on a Linux machine I can use ping. On a Windows machine I can use ping. On a router I can use ping. On a switch I can use ping. And this one is from a switch. Okay, S1 usually means switch 1. I'm pinging this, but the output looks a little bit different. I get these exclamation marks when it's working. I get a dot when it's not working. Okay, so you can see that the first one's missing, but after that, then 4 is working. So for me, that's basically working. If it's not working, I wouldn't get any exclamation marks. And this other one is me pinging a IPv6 IP address. So it doesn't. We can use ping for IPv4 and IPv6, but you can see that I wouldn't want to use it for IPv6. That's a lot longer IP address to type out. Okay, I wouldn't want to use it all the time, to be honest. Okay, so the ping command is an IPv4 and v6 testing utility, and we use the echo request. If the reply is not received within a certain time, ping provides a message indicating that the response was not received. So that's a good point. If you don't get a reply by a certain time, it just says it's not there. Because reality is, it's if you go into a empty room, if you go to a room and you go, hey Paul, right. See, if he's there, he's gonna reply, isn't he? But if he's not there, no one's gonna reply. Or if he's unconscious, he's not gonna reply. But I, as a human, I know if I don't get a reply within a reasonable amount of time, I can assume he's either unconscious or not there. So that's what's happening with this ping request. If it doesn't reply within a certain amount of time, it's going to assume, it's not going to assume, it's going to say it's not reachable. We talked about the loopback IP address, so that's for diagnostics. So we can always ping our loopback, even if we don't have a network plugged in. I'm not going to unplug myself because I'll lose the streaming to the people online. But I can always ping my loopback address, even if I don't have a network card, even if I don't have the Ethernet cable plugged in, or even if I have not joined a Wi-Fi network. Because that's a loopback address. It's, as the name suggests, it's as if you think of a cable that's going in and coming back, going out and coming back in. It's for diagnostics of your own computer. It's just testing whether or not your TCP/IP is working correctly. So basically, you always get a response if you have TCP/IP installed properly. An error message when pinging this IP address indicates that the TCP/IP is broken or not working properly, and you might have to reinstall the TCP/IP protocol stack. And that rarely happens, to be honest. Rarely happens. So obviously, if I can't get to where I want to get to, the first thing I need to test is whether I can ping my gateway. If my gateway isn't working, I'm never going to get to wherever it is I want to get to on the internet or on another network. So ping the gateway is always a good sign because you know that, hey, if I have a gateway, that's on my network, and if everything else is not working, that should work. And pinging a remote host. So pinging a remote host, what's that? Ping can be used to test the ability of a local host to communicate over the internet networking. And a local host can ping a host on a remote network. A successful ping confirms everything's working in between, like I mentioned before. But this note is interesting. Be careful. Just because you can't ping it doesn't mean they're not there either. Of course, you're probably going, what? What do you mean? Are we just talking about diagnostics? Because you've got to understand that, hey, from a point of view of networking, yes, it would be good if they respond. But from a point of view of security, should you respond? Should you be talking to strangers? If you had a child and they were going out to the mall, and just because someone said hey to them, do you think they should start talking to that stranger? No, bad idea, right? But don't forget, the internet is full of baddies. We have to assume that. So if your computer is constantly saying, hey, I'm here, and people are just doing a ping, hey, I'm here, doesn't that make you a target? All right, so hopefully from the other subject, you would have learned that by default, your Windows computer has a firewall. And by default, your firewall is going to block ICMP or not allow it. So let's actually look at our advanced firewall. Okay, let me just start up with control panel. Sometimes I like to just go straight to the tool, but sometimes it doesn't let me. So let's just go straight to the firewall advanced settings. And you notice I'm connected to the domain network. So that's the profile that's active. So if we go to inbound rules, we can actually look for ICMP or ping. Let's see if we can filter by no. Okay, let's go by protocols. This is any, and let's see. Oh, here's a whole heap of ICMP stuff. So if we look at this one, echo request in. Okay, that's so direction of the communication is important. So this is not my computer going out. This is other computer coming into my computer. So it's the inbound rules. Okay. So if we have this echo request in from anywhere on the private profile and public, private and public, it's allowed any, but you notice it's not actually on. You see all these green ticks, that means they're on. So this one's there, but it's not turned on. So if I enable that rule, then it will be allowed. That's the same. This one's exactly the same, but it's on the domain profile, which is a different firewall. So right now we're connected to the domain. So I'll disable that rule, which now turns it off, but I can enable that rule. Oh, well, let me try this thing, okay? So let's try this. So IP config. All right, so I'm going to get you guys to test this for me. So on your own computer, start a command prompt. Okay, I want you to ping, PING space 10.62.3.194. Tell me if you can get a reply or not.
I can.
You can? Oh, good. Not bad. Why? Now I think one of these ICMP rules is allowing the ping. All right, so let's have a look at which one's on. This one's on. This one's on. This one's on. Echo request. This one's on. Okay, and that's on the domain. So okay, so that's good. It's you can get a reply, right? Yep. Okay, I'm gonna. Oh, can I? I can't turn it off even. Unfortunate. It's this one that's allowing it. So basically, there's a lot of ICMP rules, and obviously our domain administrator here has applied this rule for one reason or another, and it's allowing the ping. So unfortunately, I can't even close it. But let me see if I've got a virtual machine. So So the problem is when we are being managed by another administrator, they don't necessarily know that I want to do certain things as a demonstration. VMware? Huh. I don't even think we have VMware installed on this computer. Oh, yes, we do. Why didn't it come up? All right, let's see what we've got here. Okay, we've got my Windows. We'll remove that one. Got Windows 10. Okay, so that's on the host only. We'll change that first of all. We'll change the bridge network. Remember, the bridge network is our physical network. So if I want you guys to be able to ping me, I have to be on the bridge network. Let's turn it on, and we'll see what happens here. Okay, obviously, this virtual machine should be a standalone machine, meaning that the only administrator is the administrator that's logged into this computer right now, which is me. Whereas on the physical machine, we're in a classroom right now. And obviously, this classroom computers are managed by the TAFE SA ICT team, which is what should happen. And they're doing a really good job in the sense that they're configuring it based on what their security policy is. It's just that when I want to make demonstrations and do strange things with the computers, I'm locked away from doing it, which is a good thing as well in normal practice. So bear with me while that's loading. Okay, here we go. Let's see. Password 1. And let's see if we can do some demonstration that makes sense or not sense. Nonsense. All right, so I first of all got that message on a new network, which is good. Let's go to control panel again. All right, so, and I'll start a command prompt as well. It's a little bit slow today. All right, can I get you guys now to ping 10.62.3.44? 62. It's on the screen, so 62.3.44. Tell me if you can or cannot pin.
Timed out.
Timed out. Okay, so this is more like it. So the default action of your Windows 10 or Windows 11 is to block pings, especially if it's on a public network. So let's see, what are we on? We're on a guest or public, which is what I expected, because this is not part of the domain, so this is why it's not on the domain network. So let me see if I can go to the firewall rules and make it less secure. All right, so if we sort by the protocols again and look for the ICMP version 4, and if we let's expand this rule again, ICMP echo request, local subnet, any. So this one's any, so going from anywhere. So we can also, with the firewall rule, we can decide where is it coming from. So I'm gonna do. So the any is going to let everyone in, regardless of the internet or anywhere. So let's enable this rule. Can I get you the ping again? Same IP address, ping again. What's happening now? Are we getting a reply?
Mine's still timed out.
Still timed out, same as yours, my friend Harris?
Yeah.
All right, let's look. Oh, no, sorry. Here's the issue. I didn't read this properly. It's on the domain profile, isn't it? So the domain profile is not what we're connected to. We're connected to the public network, if you remember. So I'll enable this rule instead. Try it again.
Still timed out.
Still timed out. All right, let's modify this rule then. This rule is predefined and properties cannot be modified. Okay, well, in that case, let's disable this rule and we'll create our own rule. Yeah, let's create our own rule. Okay, so program ports custom. All programs, yeah. ICMP version 4. Next one is any IP address. Any of my IP address from any IP address allow this connection, yes. All networks, yes. And we'll call it allow ping. All right, so let's see where is it? Allow ping, it's on. Okay, can you ping that again?
There we go.
It's working now? All right, so with the problem with these predefined rules, it's sometimes hard to work out what they're doing without investigating very closely. But now I've actually created my own rule. I can actually configure exactly what I want. All right, so that's that. Let's get back to our PowerPoint. So what am I saying? What am I saying is this point. No, many administrators limit or prohibit the entry of ICMP messages. Therefore, the lack of ping response could be due to a security restriction, just like the firewall we demonstrated. Okay, not that it wasn't there, not that the machine wasn't working, but because the machine is not allowing ping. So sometimes you gotta know who you're pinging. So for example, you're pinging an individual computer like a host computer, that's probably what you're gonna expect. But if you're pinging something like Google, you know that you can get a response and should get a response, then that's more of a better test. Trace it or trace route, we talked about that, but that gives us basically a utility that's used to test the path between you and the destination you want to get to. And we'll continue to, we sort of talked about this as we're talking about it. That's all. That's it. I'll show you one more command, okay? So we talked about tracer and ping, but what if you wanted both? If I wanted both, I can do what's called path ping. This does take a lot longer, but what that's actually going to do is that it's going to show me the tracer path, and also then it's going to ping each one as you get there. And basically now it's going to compute the statistics, and this is the part that takes longer. And basically this combines the benefits of tracer and ping, and basically gives us the benefits of both. But to be honest, I don't use this too much. I use ping all the time. I use tracer maybe a little bit of the time, and I use path ping when I'm demonstrating to the students, so hardly ever at all. Okay, so but that's another thing, and this is going to compute the statistics. So I'll give that a chance to run in the background, but that's today's presentation for ICMP. So what I want you to work on is either your assignment or the labs. Okay, so if you're not ready for the interview, I would suggest you need to prioritize getting you ready for the interview for next week. But there is some packet tracer labs here as well, but reality is I sort of was demonstrating a lot of that as we're doing it. Okay, so work on that. Let's go back to my path ping and see if it's done that yet. Nope. I'll leave it going, and I'm going to go to the toilet, and I'll come back, and hopefully that's finished. Okay, I'm just going to lock my screen now, but I'll stop, and now I'll keep the recording on just in case. I left it sharing, and then I just came back and stopped sharing everything. Okay, so getting back to what we were talking about, when we stopped our presentation, we were leaving it for computing the statistics, and it said it would take about 300 seconds. I went to the toilet, came back, and it's finished. So basically, like I said, it's basically a combination of ping and trace it. So it works out the path that your packet took to go to the destination. But at each one of those locations, it actually did a ping request as well. And basically, it doesn't mean all these things are going to respond to your ping and so forth, but it's giving me all those statistics. But by the looks of it, source sent, it's giving me 0%, which is not sure why 0% at this point in time, because definitely it should be pinging some of them. But that's what you see. But like I said, path ping is not something I use all the time. Ping is probably the thing I use all the time. Trace it sometimes, and path pings only during demonstrations in class. So that's it. So basically, we'll finish off there with the recording. And just